329, longest increasing path in a matrix. Given an integer matrix, find the length of the longest increasing path. I guess this is actually what the name suggests. When you cell, you can move up, down, left, right, no diagonals, or move outside. Okay. Start with 1, 2, 6, 9. Okay. 3, 4, 5, 6. Okay. Huh. Um. Hmm. I mean, there are a couple of approaches that I'm thinking of taking, and that's why I'm like, I don't know. Uh, well, one is a little sad that they don't tell you what n is because that actually, uh, determines how to attack this a little bit. In the sense that like if n is 10, then being the size of a thing, then this is way easier. Versus if n is like 1,000, then you have a million cells that maybe is a bit trickier. Um, but it still essentially comes up to like, okay, you have a graph, this is a DAG, um, right? And then you just try to find the longest path in the DAG, which is a very standard dynamic program problem. There's what you call it, uh, an n square algorithm for it, where n is the total number of cells in this case, right? Um, so I don't know. Uh, yeah, so I don't know how I want to attack this only because I don't know what n is, and that may change a few different things. Let me see if there are any. So that's one formulation of the problem that would clearly be correct uh, if time is not an issue, right? The n squared is pretty good. Um, and you can maybe even do an n log n type thing, which for, am I thinking of the right one? Yeah, longest increasing subsequence is log n log n, right? So maybe that's good enough. But that's really, at least it's not tricky, but it's just not easy. Because I think in that case you have to do like topological sort to get the DAG. I guess that part's not that hard, and then you just um, yeah, and then you just do the n log n longest increasing subsequence. I guess uh, maybe that's fine. If I want to do that, that's a lot of. I think that's maybe right. I mean, I don't think you could do an O of n where n is the number of cells. So maybe n log n will be fast enough. 3, 4, 5, 6. Okay. Yeah. Okay. I mean, I guess so. Let's do it that way. Do I remember the? I'm just thinking right now whether I remember how to do the longest increasing subsequence or longest. I guess now that no, the longest increasing subsequence. I don't think this redux because this is a graph. Because you're not looking up just any number that's smaller, which is where the binary search comes from. So we end up being n square for the longest increasing path in a thing, but okay. Well, let's let's think about how I want to do this first. I guess let's start with the topological sort, and then flatten it to an array with elements, and then find out the longest path. I guess actually no. Well, the general longest path in a DAG would be okay. So I think I got this now. Now that I was thinking a little silly, because I was thinking of the one where it's not. It's actually its longest path in a DAG is actually O of Y, not O of it. The the n squared comes from the fact that in at least in certain formulation of the problem, at least for longest increasing subsequence, the n squared comes from the fact that it's O of y, where n is v for the number of vertex, and you have, in theory, v square edges. But in this case, there's only 4 edges. So in that case, the longest path in a DAG will be just O of n, which is, well, I mean, it's linear in terms of the space, in terms of the input. So I don't think you could do much better. So, okay. So I talk a bit, but I think I have a good plan to attack. 6 minutes of just babbling. But you still need that topological sort, which is also B plus C. But yes. Okay. So I'll sort it first, and then yeah. Okay. Now, right now, I'm just thinking about how to represent it, because you could represent it as a very naive, like cell to in out degree type thing for topological sort. But actually, I think I could do better. So, because you could rely on the graph to make it implicit. So yeah, on the in degrees rather. So yeah, okay. So the number of in degrees is the number of for topological sort purpose is I guess let's figure it out. It's just the number of also I think someone on Reddit or Leetcode or someone was complaining about the N and M, but it doesn't really matter to me. Okay, if it doesn't matter, then I should fix it. That's fair. I'm talking to myself, but also I should change it to not N and M. But anyway, I forgot what I was saying. But degrees is equal to, let's just start with 0. For well, okay. Now I'll just set up to it. Which there's an easier way to just initialize an x by y matrix. I mean, that's the thing I miss from C. And there might be, but like, well, I know that you could do stuff with like numpy or something, numpy, but I don't know. Python experts, let me know how to clean this up. But yeah, okay. For x in range rows, y in range columns. Let's just set up that handy direction thing. No diagonals, but I think it said no diagonals like a couple of times actually. But okay. So for dx dy and directions, okay, now we want to set C for current, keeping my notations consistent. Okay, so now let's say if x is equal to rows and columns, then okay, if C the matrix of this is, so we want in degrees, so if this is smaller, then you can only come from there, so you want to do the smaller first, so then okay. I think that's right? And then now we do that sets up the in degree of each cell, and then now we set up the topological sort. And actually, I think from this point, maybe not actually. Do that. What's it called? Pen. Alright, let's just print out a queue real quick for the first poem. It should give us the bottom two numbers. Just a sanity check. 1, 2, so 02. Oh, and 4, because it's surrounded by small numbers. That's a good point. Yeah, because you can't, that means no numbers will fall into it, just like a topological sort, right? Okay. So it is even more correct than my assumption was, because I didn't really look at it. But okay. And now for the top, what does it mean to do a topological sort? Now we want the reverse of this. How do we want to structure the dynamic programming? Do we I mean, this is a DAG, so I guess it doesn't really matter. So then that, the current, what is equal to that? Let's do xy. Okay. Well, let's just do best is equal to 0, though it really shouldn't be 0. Return best. I guess let's actually just store another one for distance. Let's say this is let's just negative 1 maybe. It's one the longest, so okay. Yeah, okay. Does this matter actually? Now that give me a second. I think the order. I'm right now. I'm just trying to be a little bit mindful to make sure that I have the order correct. Because I think yeah, even in this case, well, look at example. Like imagine 2 gets relaxed first, and then it goes to 4, 5, 6. I mean, I think in this case it doesn't change. But what if there's a 1 connected 2, but then your orders is such that like okay, let me copy and paste this for illustration. So right now I'm thinking about this case where you have, let's say we change this to 1 and then 0, right? So in a topological sort, at least the way that I did it, you get rid of 0, so that's, do, and then 1 next, and then we do the 2. But let's say for whatever reason you pick the 3 first, right? Well, in this case, this is only going to be 1. This is only have the value of 1 as its best instead of 3 or 4 actually, right? So when you update matters, so okay, that's fine. So no, but that's fine. So okay, so we should update best. So I think it's just it's been a while, but it's returning the distance thing. The best is when you relax, not when you put in the queue. Because in a lot of cases with breadth first search type things, which this is not, it's the topological sort, but with breadth first search where the coding is very similar, when you relax the, like it doesn't matter whether you do certain operations when you insert the things into the queue or when you dequeue it, but in this topological sort, actually you wanted to do things when you pop it, because when you enqueue it, it might not be good enough quite yet. Because by the time you pop, then everything should be on the same level. Yeah, because because you only put things in a topological sort if it has no dependency. So then everything you probably independent. Okay, that's fine then. Okay, yeah. Also, thanks for following construct SSPM. Is that Smash Brothers? No, that's that's SP. Okay, never mind. Okay. So again, we could reuse direction. Oops. Yeah. Trouble typing. Again, maybe this should be a helper. And also by maybe, I mean, I definitely should have been, but it's okay. Now I think I want the other way. So okay, now we're checking a number. Let's say we're at 4, and we're bigger than the adjacent numbers. Okay, actually I guess it's the same. If we're bigger than adjacent numbers, we take the max distance from it. Okay. What was I thinking? I had a thought. Man, I hope it doesn't come back to right as when I was typing. I was like, I have to, I would, I should check for this, but then I forgot when I'm doing it. Okay, well, yeah. Okay, I don't remember what I was thinking, so I hope it doesn't come to bite back me in the ass. But okay. But actually, and the other thing that we want to do while we're dequeuing is check to see if that or decrement the in degrees of numbers that. So okay, so in this case now we so I guess this is an else with if because if it's equal then we just don't care. Then we actually relax the degree. Oops. Like in the topological sort, and then if that degree is 0, then we queue it. Oh, and now we have to check the max. I guess oh yeah, the thing that I was wanting to do is here when we dequeue, we have to set the distance to 1. Nope. That's what I was remembering. Okay. And then now, we'll probably just check here. Okay. Hopefully this was a better showing than the last part where I just had so much issues. Okay, that's a degree or degrees. Is that why? Well, it was worth a shot. No, but okay. Output 1. I don't return anything, so that's okay. We did check that it inputs are correct, so let's take a look at how it is popping. It could be just something as silly as the base case. Tell you that maybe I mixed up the C and the Y's. So I think all the distance should be 1 anyway, but I just changed that. But I also forgot to add 1. That's the difference between all the relaxing. Yeah, okay. So that's actually an easy fix. I want to say it's probably Leetcode that's having issue, but who knows? Maybe it's my code. My code is taking down the Leetcode service. No, not really, but okay. Um, hmm, that's weird. Is it? Hmm. Okay, so we lack 0, 2, so the 4, so then the 2, 1, which is the 1, and then the 1, and then after that we do the 1, 1. Oh, I'm just being dumb. I need this in the end after it updates. Whew, okay. Okay, let's try the other one. Not in a rush. I don't need to run to the bathroom, so. I think, yeah. Okay. My default case is 1, so I usually would check maybe I should check an empty array. They don't tell you. Okay, well, still hate that they don't tell you stuff like this, but okay, fine. I said it out loud too, but oh well. Sometimes, 0, I guess. Should have just tested that. I don't even know if that's right input, so some, I don't know. A little sad, a little salty, but it's fine. This one I can handle. uh, well, I'll be less salty if it doesn't take that long to run, but okay. If this is 0, I would be a little sad. Okay. Wow, I'm slower than everyone else, so maybe there's a even easier way. Uh, or maybe it just gives us a very, I mean, I don't know what n is, so maybe I'm doing something crazy. Like maybe there's some depth first searchy thing. Because my code is pretty, it's like 48 lines of code, which is not that bad. I mean, everything is very straightforward. So yeah, oops. Man. But yeah, I mean, I also don't know if, like, I could imagine if n is like in a weird way, then, maybe you could go backwards. But I guess backwards is the same, right? It's just longest decreasing path is the same as the longest increasing path. But, all right, cool. Uh, yeah, I mean, I, I want to say topological sort is something that's like very fundamental in general. I feel like in competition and contests, but and there are two ways to do it. Maybe that's the other thing. Maybe the other way to do it is that first search, uh, uh, what you would call it, that first search based topological sort with what's his name, Tar Yan, I don't know how to say it, Tarjan's algorithm. Um, but maybe that's faster, but I don't know. But either way, this is O of n in terms of the number of cells. So I don't feel super bad about it. Thought it'll be faster though. No, no, why it's so slow. I don't know what n is, and I don't know what the cases are. But I mean, I'm just more salty that I got a one-time error because they choose to give you an empty array or empty matrix. But yeah, I feel like topological sort is pretty fundamental. But I also haven't, to be honest, I don't think I've ever seen it on an interview. I feel like there is one. I have a vague collection of someone giving it once or getting it once, maybe, but I don't really remember it. So maybe I made that up, or maybe I was thinking about giving it to someone. But yeah, in general, I feel like I've never done it, but or never seen anyone do it in an interview. So I think for an interview problem, maybe that's okay, or like, I mean, it's okay to not focus on it on an interview problem, but yeah, oh, did I talk about complexity? Yeah, I mean, it's just O of n in space and time, where n is the number of cells. So, which is rows times columns, or width times height, or whatever you want to call it. of the matrix. Uh, it's pretty straightforward. I'm surprised I feel so fast, or that I'm so slow. Maybe I'm allocating memory in a weird way. That usually is a thing, but maybe deck is slow when n is big. But I can't imagine so. These should be all one operations, right? Append. I mean, all I do is append and pop. Um, I'm not sure. Maybe I just spent a lot of time allocating memory. Hmm. Yeah. But yeah, in any case, for an interview, yeah, again, maybe same as that of Bob. Good luck. I think I don't know if you do get this on an interview. I don't know if the expectation is that you would code everything necessary. Maybe it could be like near the end of the interview, and you discuss ways to kind of attack this farm, and maybe and in that sense, you would just kind of solve it on a verbal way, like verbally instead of coding it on a whiteboard or anything like that. But otherwise, because it's kind of tricky, I think, to code correctly in X amount of minutes on a contest. Sorry, in an interview. I mean, I took half an hour of that on this problem, though. I think I want to say a lot of it was talking, and not. Well, I spent 6 minutes of talking. I think I talked about that. So I still spent 20 minutes coding. So I definitely could probably be a little faster. Though I think I was talking while I'm doing this. So there was this plugging thing where I put this here. But it's not that much on code. Like 20 minutes is like 2 lines a minute of code. That's really the slow typing speed, right? All right.